When I came to Congress almost 10 years ago, the first thing that happened, and Argonne National Laboratory is in my district, was that the president cut the EMT, the electrometallurgical program, by $20 million. And I was hysterical that I thought this was in the first month that I was here, and I needed to get that funding back, because I really do believe and have long been an advocate in the recycling, reprocessing of spent nuclear fuel. Well, I did get the money back, and the program continued to conclusion, and I know that there are different processes, the Purex, the Urex Plus, some have mixed actinides, and so the cut down on the proliferation. But I think the three issues, or the two really, the pure plutonium and what to do with the waste are key issues. But to me, I think we should be moving much quicker than we are. And when I was the chairman of the Energy Subcommittee in the 108th and 109th Congress, we really worked on GNEP and trying to develop that. There was one sticking point, and that was that we asked the Department of Energy to do a comprehensive systems analysis rather than move right to what we thought was commercialization. And there was a disconnect there, and I think that really, it slowed down the process, but I think we would be a lot further along right now if we really had turned to the systems analysis rather than trying to the construction of a commercial scale facility. And the problem was then that the funding was cut until that systems analysis, or trying to get that, which I was not a appropriator, so I was not involved in that, but the Appropriation Committee felt the same way. So I would like to know from Admiral Grossman, where are we now as far as moving ahead? Congress, the GAO, and the National Academies, I think, would be more accepting of what you're trying to do to close the fuel cycle, and I think this is the most important issue that we're facing is finding alternative energies, and it has to be nuclear. I guess I come from a state that 50% of our electricity is nuclear, so we're used to it, and really want to see what goes on. But I just think that we're spinning our wheels again. We're just sitting around waiting and to say we'll do it in the future. The costs only go up. The lack of nuclear energy is only going to hurt our country. We see all over the world all these building of nuclear plants that we're sitting, and reprocessing plants that we have one in Illinois that was built and then shut down by Jimmy Carter. There's at least five others that were built at that time.
Well, Congresswoman, I take your points, and I think they're very good ones. The reasons to reprocess are, in my opinion, are twofold. One is to get additional energy out of the uranium that you dug out of the ground. I mean, uranium and the other fissionable natural material, thorium, are limited resources. So if we look ahead, if we say nuclear energy is going to be an important element of our energy portfolio for the next 100, 200 years, then I think if you put it in that context, then resource utilization, not just the current market price of uranium, is an important consideration. In addition to that, the technologies involved in reprocessing at an industrial scale are difficult. You take highly radioactive material, and the first thing you do is dissolve it in hot nitric acid. That being said, resource utilization, the other is with increased resource utilization comes a waste disposal problem at the end of the cycle that is easier to manage. The waste is less toxic, less radioactive for a long period of time. So those are really the goals of reprocessing and then recycling. And GNEP, of course, has proposed a separation of used fuel into its components and burning the particularly difficult ones, the long-lasting, highly radioactive ones, in a fast reactor kind of technology. The systems analysis that you talk about to support that is ongoing. I think frankly, it's limited by the number of uncertainties in what's it look like at a commercial scale. What are the economics going to be? So to move forward, what we have to do is we have to both do the research and development and involve the industry along the way.
If I might, though, if we're going to have to deal with the waste, if we put what the waste that we have now that's already accumulated, we would actually fill Yucca Mountain. If we were to be able to do the reprocessing, and if we would be able to burn and reburn that waste, that we could have a facility that would last for over a century. And I think we just have to make up, we can go ahead and build these plants and have more waste, but at some point we're going to have to decide when we can use Yucca Mountain.
Yes, ma'am. Those are the gains, that we can reduce the need for a geological repository, reduce the waste burden. The costs of the development of the industrial scale reprocessing technology, the resolution of the uncertainties. The principal uncertainty is, we know at a laboratory scale we can do the kinds of separations we want. We can parse the fuel. Can you do that at an industrial scale? Because it really does change. And then the other is, can you make the fuel that you want to burn, the particularly what I'll call the bad actors, can you make that, and can you recycle it effectively? And there's just a lot of technology unknowns in that, but the only way to resolve them is to do the research and development, involve the industrial components at the right pace, at the right level, because this is not just the business of laboratory scientists, it's the business of industrial operators, and then we'll know. Then we'll know whether or not we want to do it.
Thank you, Admiral, and thank you, Ms. Biggert. I'm having to deal with an issue collateral to this. I'm sorry to be coming and going.